Welcome friends. Today we discuss about solve some problems related to fifth unit. Okay, already I explained the psychrometric chart. The chart having x-axis is stable temperature and y-axis is humidity ratio. Nothing but specific humidity or moisture content. Unit is kilogram per kg of air or otherwise gram per kg of air. Okay, and some more values are plotted in the uh, psychrometric chart. Those are specific volume. The specific volume lines are the this is a specific volume lines, and the wet temperature lines are then is 45-degree inclined, and specific volume lines are slightly inclined with vertical. Okay, very steep lines. You can, if you have a point in between the two lines in the chart, they have mentioned different values. For example, in wet bulb temperature they are giving 20 and 25, but I need wet bulb temperature for 22. I approximately said this is the wet bulb temperature of 22. Okay, 22. Similarly, the relative humidity, those are 50 and 60. Okay, but I need 55. That line is lies in between like this. I can approximately I can assume, or I can draw that in between values. Okay, you can understand this concept. These things are the psychrometric chart, and the data. This is the enthalpy line, and this is the Woodruff line, y-axis. These things. Okay, already I detailed explained the psychrometric chart in previous classes. Okay, today we discuss about the psychrometric problem related to psychrometric chart. What are the psychrometric process? This is also discussed in earlier classes. Those things: sensible heating, sensible cooling, and humidifying, dehumidifying, and adiabatic mixing, and evaporate cooling. Okay, this is some important psychrometric process, and also some combination of process also there. Okay, also some combination of process is there. Okay, those are cooling and dehumidification, heating and humidification, such things. Okay, then today we discuss the problems. One is atmospheric air at 1.0132 bar has variable temperature of 40 degrees Celsius, and WPT means wet temperature is 25 degrees Celsius. Find its RH. The 2 mark question. Atmospheric air at 1.013 bar is atmospheric pressure. So no problem. The main data is the dry bulb temperature is 40 degrees Celsius and wet bulb temperature is 25 degrees Celsius. Find its relative humidity. Okay. First of all, first we locate the values in psychrometric chart. If you find out any value in a graph, we need two values. We need two values, x and y value, or any two parameters. This is mandatory. Okay. In other ways, we cannot locate the point. But in some cases, we need one value or zero value. For example, origin of the graph is one point. Okay, but if we want to locate that point, it doesn't have any data. Okay, because the origin is 0, 0 comma 0. It's everybody knows. And another example, if you locate a point in a x-axis or y-axis, you need any one point. The other value is 0. For example, if you locate the point in x-axis, what is the x value and y value is 0. Similarly, if you want to locate a point in y-axis, y value, y having certain value, x value is 0. Okay, this 0 comma 4 or 4 comma 0. At that instant, we need only one data. But in the region, the space region, want to locate any point, we need two data. It is mandatory. Okay, therefore in that problem they are giving two data. One is stable temperature, another one is withdrawal temperature. Okay, what is the relative humidity at that particular point? The question. Okay, first explain with my rough diagram. It's a psychrometric chart. First we locate the point. The dry bulb temperature is 40 degrees Celsius. Therefore, in dry bulb axis, you take 40 degrees Celsius and put a vertical line. Okay, put a vertical line. (40°C). Put a vertical line. Okay, 40°C. You put a vertical line. Sorry. From 40°C. Okay, then another data is 50%, sorry, 25 degrees Celsius. 25 degrees Celsius WBT. In the WBT is located in an inclined manner, which is this is the WBT for 5, 10, 15, 20, 25, 5, 10, 15, 20, 25. Okay, for I need this value only. Therefore, from 25, I draw the line in parallel to the enthalpy line. Is wrong. Yes, the horizontal line is wrong because the withdrawal line is the inclined line. Therefore, if you follow the inclined line and intersect the that vertical line from the 40°C stable temperature. Okay, therefore we get one intersection point, which is our required point. Okay, again I tell we have two data. One is WBT and another one is dry bulb temperature. First, what the dry bulb temperature is 40°C. From the x-axis, from 40°C, draw a vertical line, and then WBT lines values are in the attached in the extreme curve. Therefore, the value is 25°C. From the 25°C, draw a line is parallel with the inclined line. Okay, not a horizontal line. Okay, so parallel with the inclined line. Therefore, the two lines are intersect at a one point. That point is our solution. Okay, from that solution, what is the curve? This curve is represent the relative humidity. Okay, this incline curves starting from bottom to the top is a relative humidity lines. Okay, already I said. Therefore, at the particular point, that passing curve is our solution. That value is nearly 30%. Okay, because that relative humidity is 10, 20, 10, 20, 30, 40, likewise increases. Therefore, approximately I draw the values. I get one intersection point At that point, the value is approximately 30%. Okay, answer is relative humidity is 30%. Yeah, this is the how we this how we find out the unknown values with the help of known values. Okay, first we locate the point with the help of these data, and then once we locate the point, then we find out the another data intersect or passing through that point. Okay, thank you. For example, in the problem, if we calculate, they are also asked what is the specific humidity, the moisture content. Therefore, from that point, I mark one horizontal line which points that value. This value is the specific humidity or moisture content. Okay, for example, 10, 15. Here 10 is this, here 10, here 15. Therefore, that our value is in between the 10 and 15. Therefore, approximately I take 18 gram per kg of dry air. Okay, which is the approximate answer, because in the chart you cannot measure the accurate value. Okay, some human error are there. Okay, this is one type of problem. Then next problem. Next problem also similarly like that problem. Once you understand clearly, then you can easily solve the fifth unit problem. Okay, and second problem is atmospheric air at 1.0132 bar has 20 degrees Celsius dBT, 20 degrees Celsius dBT and 60% latent. Okay, that in previous problem they are giving dBT and WBT. Okay, but here the two data are dBT and latent humidity. Okay, find the humidity ratio, which is nothing but omega, specific humidity, and overall temperature and dew point temperature. Okay, dew point temperature TPT. Okay, and enthalpy of mixture. Okay, this is also a very easy problem. First we locate the point in psychrometric chart. First primary, from 20 degrees Celsius I draw a vertical line, then the next data is 60% relative humidity. Okay, 60% relative humidity. Then this likewise the relative humidity lines are there. In that line we is 40%, 50%. Therefore, at 60% I draw imaginary line. Okay, that vertical line and the curve is intersected one point. That point is our location. Okay, from that point horizontally I draw a line from left to right is shows the specific humidity value. Okay, and also from that point I draw a line from right to left, and for top to it touches the extreme curve. From that curve draw a vertical line. Here we get the dew point temperature. Okay, then likewise from that point I draw a line in the inclined manner. I get a WBT at the extreme lines, extreme curve. Further extend the line, it intersects the entropy enthalpy curve, it shows the enthalpy value. And all unit of the every values is given in the psychrometric chart. Okay, you don't bother about it. Okay, once again I tell the psychrometric chart. This is the chart. The given values are 20 degrees Celsius. Therefore, from 20 degrees Celsius, I draw one vertical line. So 20 degrees Celsius, I draw vertical line. And remaining value is 60% relative humidity. The 60% relative humidity value is this. The 60% relative humidity value. Therefore, I get an intersection point. Okay, from that point, draw a horizontal line. We get the specific humidity value from this. The specific humidity value. Therefore, the value is in between 5 and 10. Therefore, I can take the 9 kg per kg dry air because that line is closely matches to 10. Therefore, I take 9.9 or 9.8. Okay, you can write the answers. Then the dew point temperature is, draw the line from right to left. It touches the saturation curve. From that, draw a vertical downwards line. It shows the temperature. The temperature is nearly in between the 10 and 15. Therefore, I can take 11 degrees Celsius. Okay, which is my approximation. Then from that point, I draw a line parallel to the inclined lines. It touches the saturation curve. At that point, I get the WBT value. In that solution, that value is in between 15 and 20, but that point is close to with 15. Therefore, I can take the values as 16 degrees Celsius. Okay, then further extend that enthalpy to next stage. Further increase the extend the line to the enthalpy scale. It shows the enthalpy values, which is also approximately 45 to in between the 45 and 50. Therefore, I can take the 46 kg per kg of dry air. The unit is given with the values: kg per kg of dry air, degree Celsius, meter cube per kg of dry air. Here, moisture content is grams of moisture per kilogram of dry air. Every unit is attached with the heading. Okay, therefore you don't memorize the units. This is the second example. Okay, so first and second example both are the same, but the input data are different. In the first example, dry bulb temperature and wet bulb temperatures are given, but in second example, dry bulb and relative humidity is given. Okay, with the help of these two values, I can find out that location, and from that location, I draw some another lines. That another lines shows the unknown values. Okay, this is the problem from fifth unit. Okay. Furthermore, we have two more problems in that unit. Okay, which will be discussed tomorrow. Okay, thank you. That values.